Hello everyone, hope all is well today. My name is Jalamat. The plan for today's video is to discuss the use of the t.test function to perform an unpaired t-test with R. We'll do this in a two series of videos, in a two-part series. In the first part, we'll discuss the case where we are going to assume that we have two numerical vectors, and in the second part, we'll discuss what to do when you're actually importing data from a file. Okay, so here in my R editor window, I have two commands to construct my two numerical vectors, and these are going to be our samples from our two independent populations. So I'll create x1 and x2, so I can here display x1 to you and display x2. So these are the two numerical vectors. We're going to assume that these are samples from two independent populations and that we would like to compare the two. Okay, so now before using t.test function, we should ask a few questions. The first being, do we have unpaired data? And is the data inside of two numerical vectors? And if the answer is yes, in our case it's yes, and the data is inside the vectors x1 and x2, then we can use the function t.test as follows. We put our two numerical vectors as the first and the second argument. Okay? And then I'll show you. We'll go to the output and explain what's happening. And so by default, R is going to use the Welsh approximation, and so we're assuming that our populations have unequal variances. And second line is just simply telling me, okay, which are my numerical vectors. So here it's x1 and x2. And then in the next line we have our observed value for the t-test statistic, corresponding degrees of freedom, and also the p-value. By default, R is going to assume that we're testing for the equality of the means and that the alternative hypothesis is that the means are unequal, or equivalently that the true difference in the means is not equal to 0. Okay, so this is a description of the alternative hypothesis. And then R is going to give a 95% confidence interval for the difference between the means, and also display the means for our two variables. Here it's always going to say mean of x, mean of y, but this is simply to say my first, the observed mean for the first sample and observed mean for the second sample. Okay, so this is the t.test function to use a Welsh approximation for unpaired data. Then what we're going to do is go back to the editor and ask ourselves a few other questions. Second question is it reasonable to assume equality of variances? If so, then we might want to use a student's version of the test where we pull the variances. Okay, and so to do so, we'll put in a second argument. So this will be the third argument here, where it's var.equal, var.equal, which is equal to true. Okay. And so here to do this, I'll go back into my console, and then I'll add the argument var.equal equal to true. Okay, so now it's going to be the student's two sample t-test, where it's going to be based on the pooled standard deviation. Okay, and so here again, so we have a two sample t-test, we have our test statistic, degrees of freedom, p-value, a description of the alternative hypothesis, 95% confidence interval, and then we also have the display of the two means. Okay. Now, if we are interested in a one-sided alternative, what we could do is add also another argument which describes the alternative. And so either it's going to be alternative equal to less, this is going to be a left-sided alternative, or alternative equal to right, and this is going to be a right-sided alternative. Okay, and so here, for example, if I do t.test, and then I'll keep var.equal equal to true, and this is just to mean that we are going to assume equality of variances, and then I will add an alternative equal to, in quotation marks, less. This will be a left-sided alternative. So here I look at the description, alternative hypothesis that the true difference in means is less than 0. Okay, and so I'm assuming actually that the mean from the second population is larger than mean from the first population. And then if I go to greater, in terms of my alternative, If I look at the description of the alternative hypothesis, here I see that the true difference in means is greater than 0. And so this hypothesis is assuming that the mean from the first population is larger than the mean from the second population. Okay, so this is the use of the t-test function to perform an unpaired t-test with R. Have a good day.